This is problem number 25 from the 2005 AMC8. And it starts talking about a square with side length 2 and a circle that share the same center. And it says that the total areas of the regions that are inside the circle and outside the square is equal to the total area of the regions that are outside the circle and inside the square. What is the radius of the circle? And so essentially somehow we've got to connect the circle and the square together. And if you go through and try to do this in a way that you draw triangles and do things like that, it can get kind of complicated. But what you can do is use a very simple fact in this problem, and that is that if you take these red parts away, these are the parts that are the extra parts of the circle, and then you take these blue parts away, the extra parts of the square, you're left with a region that is an overlap of the square and the circle. And so that region has the exact same area. And then it turns out, based on the information of the problem, the square and the red part and the blue part is the exact same area. And so you can draw this really important conclusion, and that is the square has the exact same area as the circle. And since the square has side length 2, the circle has it means the square has an area of 4 because area equals side squared. And so the area of the square is 4, so that means the area of the circle, pi r squared, is also equal to 4. And you just have to solve this equation. If you divide both sides by pi, you get r squared equals 4 over pi. And so you solve a quadratic by taking the square root of both sides to get r equals, well, the square root of 4 is 2, and the square root of pi is just square root of pi, which turns out to be answer number A. So the only real way to get to this solution was to make that important logical leap, which is to show that the square and the circle have the exact same area. Once you made that distinction, it just turned out to be a pretty standard algebra problem with a little bit of twist to it, but not too hard to solve.